Hello, I am Manqi Li. This is my first lab report. The setting is that a baseball moves at a constant speed without changing direction, and the aim of this lab is to test the hypothesis that a moving object with constant speed and direction has zero net force acted on it. And so why we're interested in that? That's because if we can obtain the net force of a moving object simply by observing its velocity, that will be really convenient since it's hard for us to measure the net force because it's intangible. And the physics principle that I used is final velocity equals to initial velocity plus the net force divided by mass of the ball times the changing time. And this is just a rearrangement of the Newton's second law. And the result of the lab is that the experiment of a moving object with constant speed and direction resembles the computer model that sets net force to zero. So the hypothesis is true. And then I want to discuss how I derived the experimental data. I extract the middle part of the video because in that part, the baseball is approximately of constant speed and direction. And I also set a coordinate system here. It's a specific orientation. However, even if I flip the coordinate system, I can still obtain the same results. Probably the x position of the baseball will be negative rather than positive. However, the changing position divided by the changing time will still remain the same. And I track the baseball by finding the center of mass, and then I obtain the data here and the graph here. And then I want to discuss why the computer model can predict the experiment. For this baseball, we only have two forces acted on it. The first one is the gravitational force, and the second force is the force that the table exerted on the ball. And these two forces are equal so that they cancel out and the net force is zero. And then I want to discuss the computer program. I set the mass of the ball to 0.272 and the position of the ball. I derived that from the first line of data here. And for the initial velocity, I calculate that from the first two pieces of data. I use changing position divided by changing time. And in the while loop, I set net force to zero. And I obtain the current velocity by adding the initial velocity and the net force divided by the mass of the ball times changing time. This formula is just the same as the formula I mentioned initially here. And with the velocity, we can calculate the current position of the ball by adding the initial position to the velocity of the ball times changing time. And when we run this program, we can obtain the data here. The first column is time, the second column is the x position of the ball. And when we collect the data from the experiment and the computer model here, we can draw a graph. The red line is for the experiment, the blue line is for the model. And we can find that these two lines are really similar to each other. So the computer model can predict the experiment. That means the hypothesis is true. A moving object with constant speed and direction has zero net force acted on it. However, we can notice there is a small discrepancy here. And the reason for that is that we have a small systematic error here. The x-axis is not 100% parallel to the horizontal table, and also we have random arrows. When I track the center of mass of the baseball, we can find that the points are not on the same line. So that in the following lab, I need to reduce the systematic error and random error in order to obtain a more accurate result. And thank you.